Today we're going to expand on rationalizing the denominator, and really today's a little bit of a push beyond basic rationalizing of the denominator. So first I want to do a little warm up, and I'm going to write some problems we've seen in the past. Okay, so take a moment and write these problems down, and then I want you to pause the video, just go through and do them, and I'm going to do the same. And we'll talk about what happens when we have, and this is something we've seen before, when we have this sum and difference pattern. And what we should be kind of reminded of or notice is that every time we have this, where my terms are exactly the same, terms are not changing at all. All that's changing is its addition and subtraction, my signs in the middle. It always cancels that middle term, right? So my final answer here is just 9x squared subtract 16, or 9x squared subtract 49y squared, 4x squared subtract 3. But every time this middle term cancels. And that's called using a conjugate to undo that middle term. And so our conjugate with rads, and specifically when we have radicals, is it's used to rationalize the denominator when a binomial is in the denominator. Okay, so last set of notes we looked at, well, what if a binomial is in the numerator? Today we're going to look at, well, what if that binomial is in the denominator? That really complicates things because I can no longer just multiply by the square root of 2. If I multiplied by the square root of 2, that would distribute through and it's not going to get rid of my radical. So when we have a binomial in the denominator, we use conjugates to get rid of that radical. And so we're using that sum and difference pattern. To undo this rad, I'll multiply by the conjugate, meaning if I have the sum, I'll write the difference. So exact same terms, sum and difference pattern is what I'm kind of creating there. And then just like before, whatever I multiply the denominator by, I also have to multiply the numerator by. So in the numerator, distribute, and that gives me 20 minus 4 rad 2. In the denominator, I'm going to multiply this out over to the side. I'm going to have binomial times binomial. So I'll have 5 times 5 giving me 25. And then I'll have 5 times negative rad 2 giving me negative 5 rad 2. Then I'd get positive 5 rad 2. Positive times a negative giving me negative rad 2 times rad 2, regular 2. And because we use this sum and difference pattern, the conjugate there, that cancels out the rad. That rad is going to be the only term we have. That middle term is going to be the only one that's still going to have a rad because we're automatically going to create that number by itself thing. Those cancel, leaving me with 25 minus 2, or 23, and the denominator. So by using that conjugate, that sum and difference pattern, we rationalized that denominator. We got rid of that radical. And we don't have any simplifying of rads in the numerator, so we're done. So let's look at another one. Okay, here we have 2 different rads. It's okay. To get rid of them, we multiply by the conjugate, which just means we're flipping our sign. We just need to remember that whatever I multiply the denominator by, I have to multiply the numerator by. Okay, so I'm multiplying top and bottom by 3 rad 5, subtract 4 rad 2. Numerator, we distribute. So that gives me 15 rad 5, subtract 20 rad 2 in the numerator. In the denominator, so let's think about what this is going to give me. 3 times 3 is going to give me 9. Rad 5 times rad 5 is going to give me regular 5. Now, because we know this would happen, I mean, you can look at it, but it's going to be negative 12, positive 12. They're going to cancel those middle terms. So when I have the conjugate, I only have to multiply the first and the last. Okay, in terms of FOIL, I only need to look at the first and the last. As long as I'm setting it up correctly, that middle term is always going to cancel. If you want to write it out every time and cancel it, you can. I could write the whole thing out, cancel out those middle terms. It's always going to happen as long as I'm just using some difference. So then my last terms, 4 rad 2 times negative 4 rad 2 is going to give me negative 16. Rad 2 times rad 2, regular 2. Okay, that middle term would cancel. Let me just write it out at the top here. So 3 times rad 5, we said is 3 times 5. 3 rad 5 times negative 4 rad 2, if I were to do these outer terms, would be negative 12 rad 10. And in the middle, I'd get positive 12 rad 10. And then I'd get that last term. And it's always going to be that those middle terms cancel. So if you want to write it all out, that's fine. Just remember what you have in the end. And be careful that this last term is always going to be negative with this pattern. So that's something that students miss sometime and be careful with. There's no simplifying in the numerator. Those are good to go. And the denominator, 9 times 5 gives me 45. 16 times 2 giving me 32. So now I just have to subtract that. 15 rad 5 minus 20 rad 2 over 13. There's my answer. Okay. On number 3, same idea. The conjugate here would be 2 plus 3 rad 2. 2 plus 3 rad 2. Distributing here, so now my top term has a rad as well. 5 times 2 giving me 10 rad 5. And here, 5 times 3, and then 5 times 2 is what I'll do, the outer and the inner. So giving me 15 square roots of 10. And neither of those need to be simplified in the end. Neither can be simplified. In the denominator, 2 times 2 giving me 4. Remember, outer, inner is going to cancel. So then I just have to do the last, which would give me negative 9 times 2. 2 times rad 2, regular 2. I have 10 rad 5 plus 15 rad 10 over 4 minus 18, or 10 rad 5 plus 15 rad 10 over negative 14, which we may want to write that negative out front. Like that. You don't typically write a negative in the denominator, but if you had it there, that's okay too. Okay. And same idea with the ones we were doing before. I could have broken that apart and had negative 10 14ths and negative 15 14ths, and I could have reduced the negative 10 14ths if I wanted to split them into 2 separate terms. Okay, so now on 4, we have a binomial in both places. Well, the only place I care about getting rid of is the denominator. So in the denominator, multiplying by that conjugate to subtract rad 5, do the same in the numerator. So now in the numerator, I have binomial times binomial, and things aren't going to cancel here. I got to work out what that's going to be. So 4 times 2, giving me 8. 4 times negative rad 5, negative 4 rad 5. Inner terms here, negative 2 rad 2. And negative times a negative, giving me positive square root of 10. So I need to actually go through and multiply out that binomial times binomial in the numerator when that happens. In the denominator, 2 times 2 gives me 4. Outer, inner terms are going to cancel. 5 times 5 giving me regular 5. It's going to be subtract, because positive times a negative, subtract 5. Now this one's interesting. So then this is all just going to become negative 1, right? Now I wouldn't leave it over 1, but because it's a negative, I either need to put a negative and then all of this in parentheses, or really I'm going to just go through and divide them each. You know how we can break these up? So 8 over negative 1 would make this negative 8. Negative 4 over negative 1 giving me positive 4 rad 5. Negative over a negative giving me positive 2 rad 2. Positive over a negative giving me negative rad 10. Because each of these is they're being divided by negative 1. I just went through and changed all the signs. And there's my final answer. So now I want you to try the last 2 on your own. Pause the video and then continue it and see how you do. Okay, so I stopped both of these kind of partway through. So go ahead and check what you got for the numerator here on number 5. And then in the denominator, again, we like to do first and last, which gives me 4 times 3 minus 4 times 2, or 12 minus 8, and 4. Okay, so I have my numerator from being multiplied out, and cleaning up the denominator, rationalizing it gives me 4. Now on this one, because they're all divisible by 2, I can reduce this. So all of it. I don't really have space. So I can say 3 rad 3 plus 3 rad 2 plus 5 rad 6 plus 10 over 2. Because they're all divisible by 2, I can go through and reduce this to get here. Okay, and then I could have, I guess, broken it apart more and reduced that last one a little bit more, but this is good. Okay, so when that's the case and everything can be divided by 2 or everything can be divided by 3, you should do that. I don't really care if you break it apart and reduce, but that we should notice. Now, I also thought 6 was interesting, so check again your numerator. In the denominator, I end up with -2. That's what I'm going to have here. So what I would do is I'd bring the negative out and I'd pull it through and then just leave the 2, meaning that's going to change my signs, the fact that this is negative. Okay, or really we're just reducing here. And oh, look, we'll be, okay, let's just do both. We can divide all of these by 2. So let's just forget what I said. Didn't even notice that before. So let's just divide each term here. They can all be reduced by that -2. So -2 over -2 is just going to give me 1 rad 2. 2 over -2 giving me -1 rad 6. I have no space. Negative over negative giving me a +2 rad 5. Positive over negative giving me a -2 rad 15. And then here's my final answer. Because they can all be divided by what I had left there when I rationalized, we can just go through and reduce each of them. And there's my answer. Now, if it had been just like a -3 or something, I would put the negative up and change all the signs and just leave it over 3. Or go through and reduce each of those without negative. Okay, now this is tricky stuff. It's definitely like a little bit of a push. You'll see some in your review. Certainly the bigger idea is, can we rationalize the denominator? We want to be able to do that when it's a monomial for sure. And then this pushes us to say, well, what would we do if we did have 2 terms? And that's when we have to use that conjugate.